Hello and welcome. This is going to be our lecture video for April 22nd. I'm going to be talking about how to graph piecewise functions today. Before we get started with the step-by-step, let's get just a quick definition of what a piecewise function is. So you can just write this on the back if you printed this off, or in your notes if you're just taking notes on this. So a piecewise function is a set of rules for how to change an input into an output, all right, that changes based off what the input is. And we've actually already seen one of these. An absolute value function is a piecewise function because if we drew our absolute value as a box here, it acts very different if you give it a positive number versus a negative number. If you give it a positive number, like a positive 8, the 8 just comes out the other side unchanged. But if you give it a negative number, like a negative 4, the negative 4 gets multiplied by negative 1, and this becomes a positive 4. All right, but piecewise functions, they can split up their inputs however they want. They can say everything that's less than a certain number, I want to add 2 to it, and that's it. And then everything that's bigger than that number, I want to multiply it by 4. So it looks at what the input is, and then it gives you a different output based off of that. All right. So here's how we graph these functions. So step 1. All right. We want to identify the boundary values. All right, and so we look at the inequalities. So I'll just kind of make a note here. These are the numbers in the inequalities at the end. So let's just look at this piecewise function. We've got this function notation. We say this as g of x. It just means this is our function. We're labeling the function g. X is our input. All right, this is going to evaluate to be negative 2 when x is less than or equal to 1. It's going to evaluate to be negative 6 when x is greater than 1. All right, but you'll notice the boundary value where we switch over from being a negative 2 to a negative 6 is 1. This is our boundary. Our boundary is negative 1. So step 2 is we want to draw a vertical dotted line at the boundary. All right, so the boundary value was 1, and it was 1 for both of them. That's pretty common. That'll be the same number in both. We want to add a vertical line, very light, at 1. All right, this cuts our graph into 2 strips. And we can label it strip 1 and strip 2. And if we had another vertical line, we could have a strip 3 and a strip 4. But since we're just starting this, everything's just going to have 2 strips. All right. Step 3. we want to rewrite the first equation with a y equals. So the equation is what's in the very middle there. All right, these are our equations. We'll label it equations. All right, so I'm going to take off the top of that, just the -2. I'm going to rewrite it as y equals -2. All right, step 4. In step 4, we want to dot in the first equation. So this -2 is just a y equals -2. Y equals -2 is going to be a horizontal dotted line at the elevation of -2. So there it is, dotting it in all the way across the graph. All right, but we don't connect the dots yet. We, in step 5 here, all right, we want to connect the dots in strip 1 for equation 1. And so just so you know, when we get to equation 2, that will only connect the dots in strip 2. If there was an equation 3, we would only connect the dots in strip 3 there. So here's the dots. We're going to connect only these ones over here, and we're going to ignore these dots over here. And this strip keeps going off to the left, so I'm going to add an arrow on this side, but no arrow on this side. All right. So step 6. Repeat for all equations equation 1 went to strip 1. Equation 2 is going to go to strip 2. Dot, dot, dot. All right, that says equations there. All right. Now step 7. It's the first time I think we got into step 7. So at the boundary, that vertical dotted line, all right, end each line with the correct dot. And to pick the correct dot, you have to look at the inequality that was related to that section. If you have a less than or equal to or greater than or equal to, you're going to go with a closed dot. If you've got just a less than or a greater than, you're going to have an open dot. Like a big obvious open dot. So these were closed, this one is open. All right, so let's go finish up number 1. So the second equation, I'm going to rewrite it as y equals -6. I'm going to dot in the equation y equals -6, but only connect the dots on this side over here. All right, now I'm going to look back at those inequalities. The top one has the or equal to, so it gets the closed dot. And the bottom one does not have the or equal to, so it gets an open dot right here. It's an open dot, fill in the middle white, make it very obvious. And this will always happen. You always have a closed dot either above or below an open dot. You'll never have two open or two closed dots on the same boundary. Okay, and that's all our steps. Let's try it with problem number 2. So where's our boundary value? You look at the very end, -3. So I need a vertical dotted line at -3. All right, take the top equation, write it with a y equals. So this x plus 1 is going to be a y equals x plus 1. That's a linear equation with a slope of 1 and a y-intercept of 1, so I put a point at 1 and slope of 1, so I'm going to add in these dots. Going all the way across the graph this direction, these dots come across this direction. But that was equation 1, so I only keep the dots that are in strip number 1. And we always number them left to right, 1, 2, 3, 4. All right, and these dots over here, they actually go away. We can actually erase them. We only wanted that line segment, or it's actually a ray because it's got an arrow on one side. We only wanted that ray right there. All right, on to the next one. Let's write it with the y equals. Y equals -2x minus 1. Put a point at -1, our y-intercept. The slope is -2, so down to right 1. All right, and I'm going to stop when I hit the boundary here. I don't need to keep going because I know I'm only keeping these dots over here in strip 2. All right, look back at the inequalities. The first one does not have the or equal to, so it gets an open dot. Second one does have the or equal to, so it gets the closed dot right at the boundary. All right, last one. What's our boundary? -4. Vertical dotted line at -4. Take the top equation, write it with a y equals. So it's going to be y equals -x minus 4. Let's graph that. Point at -4, slope of -1. So I don't really need to keep going that way because I need to get to strip number 1. So dot my way over this way. And only keep this section on the left of that dotted line. Even erase these. All right, second equation. Rewrite it with the y equals, so y equals 2x plus 4, point at 4, slope of 2. We'll stop once we hit the boundary. All right, put a dot at the ends of both of them, but which one are we going to fill in? We're going to fill in the top one because it's got the or equal to. I'll make this one open. Okay, well that's that for this lecture video, step-by-step binder. There's a homework. Let's go ahead and get started on that now and have a good rest of your